all right, all right. Here's Form B of graphing versus equal values method, my people. Form of B. All right, if you're not subscribed, please subscribe. Throw a like. Let me know how things are going. We're going to graph and use the equal values method. This is a partner activity. Your partner is going to graph these two equations, find the point of intersection. You're going to use the equal values method to find the point of intersection, and then you're going to compare answers, all right? Good times, good times. The equal values method says, hey, if this y equals this, and this y equals this, and this y is the same number, right? Think about it. Where the two lines intersect, the x and the y are exactly the same number. So this number equals that number at the point of intersection. So therefore, I can take this mx plus b and set it equal to this mx plus b. And now I solve this equation for x, and that will give me the x value for the point of intersection. I'm going to opposite inverse operation of minus 2x. That's plus 2x. Now I'm going to go ahead and inverse operation plus 6. That's minus 6. You got to do it to each side. Your goal is to get the variable x by itself. I want to know what 1x equals, so 3 divided by 3 is 1x equals negative 1. All right, now I'm just going to go here and say, okay, well, y equals negative 2 times that x value. So if I know the point of intersection has an x value of negative 1, then the y value is going to be what I get when I substitute that negative 1 in. All right, so that is negative 1 comma 5, which is exactly what I got on the other sheet. So my partner's answer matched. Let's go. Okay, so that's how you know you both did it right. If you don't get the same answer, then you got to go back and check it. Okay, this is going to be the graphing method. Y-intercept of negative 1, slope of down 4 over 1. Down 4 over 1, like that. Make an accurate graph. That's important. Muy importante. Accurate graph. Okay, like that. And like that. Okay, now I'm going to graph the other one. The other one has a y-intercept of positive 5 and a slope of up 2 over 1. Like so. Now I'm going to graph that line, make sure it's accurate. And right about there. Okay. All right. And then let's find that point of intersection. Looks like it's right there. And what's that? Negative 1 comma 3. Hey, that's what my partner got. That's what my partner got. So we're good. Okay, now I'm going to go back to the equals values method. Set this rule equal to this rule. That's the rule that changes the input to the output, right? It's a two-variable equation. So input, output. We're looking for the one input and output that is the same for both. Woo! Subtract 1/3. This ain't too bad. Let your calculator do the walking. When you let your calculator do the walking, you're going to get negative 1x plus 4 equals negative 2. Subtract that negative 4. Let's move that over now. Negative 1x equals negative 6. Divide by negative 1. And you get x equals 6. I'm going to go right here. If x is 6, then y is going to be what I get when I substitute that 6 in for x. Multiply by the top, divide by the bottom. That's 6 divided by 3 is 2. Minus 2, hey, that's 0. That's what my partner got. 6 comma 0. And let's move it on. Okay, ooh, we get to graph again. Y-intercept of 3. Slope of down 1 over 2. I like to do it a few times, get accurate. Go like this. And like that. And then this is standard form. So find the x-intercept. The x-intercept is negative 8 divided by 1, so that's negative 8 comma 0. So that's right here. The y-intercept is going to be negative 8 divided by 2, so that's 0 comma negative 4. That's right here. I did those wrong. The x-intercept is here. Right here. I know some of you yelling at me online. No, that's not the right point. You right. And then 0, negative 4 is right there. Okay. Oh, look at these lines. Look at these lines. Look at these lines. They will never intersect. Those are what we call parallel lines. How many solutions do parallel lines have? No solutions. So do not write parallel. Parallel is the characteristic of the lines. But there's no solution to this. And that's what we're looking for, solutions. Right? Where do they intersect? But they do not intersect. So there's no solution. Ooh, that's fun. Okay, now we're going to set equal values method. So set that rule equal to that rule. Oh, don't get all upset because your x is on the other side. It's all right. Still do the same thing. What's the opposite of plus 1/2? That's minus 1/2. Go to your calculator. 5 minus 1/2. You can write this as a decimal now. That's all right. That's a number. They're equivalent to 4.5, 4.5. They're the same. Now I'm going to go ahead and inverse operation that plus 5 over. And I get 4.5x equals negative 9. Divide both sides by 4.5. And you get x equals negative 2. Okay, now I'm going to go over here. I'm going to find that y. I'm going to put a negative 2 in right there. Okay, so now I got y equals negative 4 minus 2. Sorry, plus a negative 1. And that's negative 5. So my ordered pair is negative 2 comma negative 5. And that works. That's what my partner got. Okay, good job, partner. I'll put their answer there if I was working with a partner, but my partner's imaginary. All right, now we're going to graph it. This is x and y intercept. Cover the y. X-intercept is 9. Let's not mess this one up. I got it. Cover the x. Y-intercept is also 9 because there's nothing to divide by. Right? So y equals 9 is the solution. Now I'm going to go ahead and graph that beautiful line. Make sure you drive it through. Make sure it's accurate. Like so. And so. Okay, now I'm going to graph the other line. The other line is a y-intercept of 4. Up to over 3. I love that when you land on it. I love it. Okay. Graph that line. Whoosh, all the way through. Arrows on the ends. And that is an ordered pair 3, 6. 3, 6. And that's what my partner got to. Let's go! Okay, happy people. Good job, good job. See you soon. Don't forget to like. Don't forget to subscribe. Tell your friends. Okay.